Get an inhomogeneous Markov chain. Markov chain and gives distribution with beta equal to beta I is the invariant or stationary distribution for Pi. Now remember those conditions I wrote down. What were those conditions? One condition was that the oscillation of the invariant measures. So mu, I had something like pi n plus 1 and pi n. Their difference should be such that the terms are summable. And also I need contraction coefficient for the product starting from Pi going up to Pn to go to 0 for any I. That will now translate in terms of some condition on beta n. And one sufficient condition is this, that beta n should be B-go of log n. So that's the rate that comes out that ensures both the condition. Okay, so the condition that will ensure this is beta n B-go of log n. So you see it's a very slow cooling. Beta n grows at a very slow rate. And then there are various results on the, it's like what are the constants that you'll be getting with log n. I will not go into that. So if you want, you can study more on your own. So this is the final result. So if you let beta n grow at a logarithmic rate, not faster than that. If you let it grow faster than that, then those conditions will not be satisfied that are required for convergence of the inhomogeneous Markov chain. So then your convergence will collapse. But if it grows like log n, in fact, they have worked out some nice formula like beta n equal to some constant times log n, where they have given some nice recommendation for the constants also, okay, based on how much variation you have in the function and things like that. Okay. So anyway, I will not go into all the details there. Okay. So then finally, in the limit, I am getting to uniform distribution on the set of minima. So this inhomogeneous Markov chain will converge to uniform distribution on the set of minima. There is no homogeneous Markov chain that you can create that will converge to the uniform distribution on the set of minima. Only an inhomogeneous Markov chain will go there. Okay? And if you really want to work out the limiting distribution of inhomogeneous Markov chains using your traditional theory that you have for homogeneous Markov chains, that's very hard. Okay? It's much easier to do it through this matrix algebra and related arguments using this contraction coefficient. And that's why Dobrushin actually developed all these things. Okay? So the final result is if you do beta n like this, then xn, that Markov chain will have limiting distribution as the uniform distribution on the set of minima. So just the final result I write down for the sake of completeness.